Hello everyone. So in this video, we are going to make entire semantic search from scratch by using Elasticsearch, SBERT machine learning model, and at the end, we'll make Streamlit UI on top of everything. So we'll go step by step. First, we'll discuss how the end product will look like. Then we'll decide the architecture of everything. Then we'll prepare, process, and ingest the data into Elasticsearch database. Then we'll write the function to search the data. And at the end, we'll make a beautiful UI by using Streamlit. Let's search for make a product having a name of a bird. Search. So first results have royal peacock in the name. It is matching with like it does have a name of a bird in the name. Let's search one more thing, a very simple blue shoes. Search. Okay, the first result is blue sneakers. So the shoes is matching with the sneakers. So this is not just a normal text or a lexical search. This is an intelligent or what we call semantic search. Let's just discuss about the high level architecture of whatever we are going to make today. So we have Elasticsearch server. So basically this is the database and we'll create index in this database. So index is nothing. It is analogous to table in MySQL database in any relational database. So we'll create an index inside of Elasticsearch. And then we have a data in a CSV format. So I have taken a data of Myntra products. And this data I have downloaded from Kaggle. I'll give you the link as well in the description. So what we'll do, we'll process this data using pandas. After processing this data, we'll convert the relevant fields into vector by using BERT, SBERT machine learning models. And after converting everything, not everything, we'll just convert the descriptions of the products, not everything, not the title, not the price, just the description, because we want that description to match semantically. So that is why we'll only take description. And then we'll insert everything into Elasticsearch index. So this is the first part of it. Now, from the user side, so let's just say this is a user and user will type any keyword. So user will interact with Streamlit UI. So Streamlit is a Python library which is by which we can very easily make UI for this search. So this is the UI which I have shown you at the beginning of the video. So this is the same UI we're going to make from scratch. And user will interact with this UI and we'll write a search function inside this UI. Keyword will go into Streamlit UI. The keyword then go into the search function and then search function will talk to Elasticsearch. Elasticsearch will give it relevant results and then relevant results will be shown on the UI to the user. One more thing, we'll make mapping of this index. So what is this mapping? Basically, we'll define what kind of data we are going to insert in each field of this index. So once we do it, it will be more clear. Let's just start the Elasticsearch server. So Elasticsearch, I have downloaded Elasticsearch in this directory. As we can see here, we have Elasticsearch 8.9.1. So we wanted to run our directory from this Elasticsearch bin, and there is a file called Elasticsearch. If we run this, this will start the Elasticsearch server. So this is the server is getting started. If we wanted to check, if we want to confirm the server is started or not, we can go to our browser and we can type https://localhost and 9200. If we open this, it will ask for the username. So username is Elastic and we have a password as well. So if you install Elasticsearch for the first time, it will give you the password as well. So I'll paste the password here. And if you see the screen, that means our Elasticsearch server is running perfectly fine. Okay. Now, this is the folder I am in. This is the semantic search folder I have made. Actually, I'm recording this video for the second time. First time I have recorded the entire video and I forgot to plug the mic. I know, it happens. So, anyways, we are in the semantic search folder, and I have downloaded this CSV file from the Kaggle. I'll share the link in the description as well so that you can play around. And we'll create one more file. We'll call it index data, and I'll use Jupyter Notebook, IPyNB, basically IPy Notebook. This is the Jupyter Notebook extension. Okay, so first of all, I'll open the terminal, and in this terminal, I can use the basic Python installation, but I wanted to create the environment. So I'll create the new environment. We'll use Python 3 -m venv module, and we'll call our virtual environment as venv itself. This is just the basic practice which we generally use. Okay, so the environment has been created. As we can see, this is the folder. Now we'll check into this environment. So we'll write source venv /bin/activate. So if you see here in bracket, this is venv. That means our virtual environment is activated. Now I need to install some libraries here. So pip install Elasticsearch. This is the first library I wanted to install. Second, I want to install pandas. Pip install pandas. This is getting installed. This is done. Now we'll import from Elasticsearch, import this class, which is Elasticsearch. We will run this. We'll click on Python environment, virtual environment. And running cell with virtual environment requires the IPy kernel packages. We'll install this as well. So to run this Jupyter Notebook, VS Code requires some other dependencies, which is getting installed here. As we can see, this is done. Now we wanted to connect to Elasticsearch by using Python. So here we'll start with the variable es, and we'll use this class. In this class, we need to pass two things. First, we need to pass the URL on which the Elasticsearch is running, and the username and the password. So the first argument here is the same, https://localhost:9200. We'll put comma here, and then we want basic authentication. We'll pass this as well. And first, this is the username, and I wanted here the password. So I'll just copy paste the password here. Done. One more thing we wanted to do here. So from Elasticsearch 8 onwards, Elasticsearch has by default enabled the security. So we have to pass this CA certificate path. So this certificate is present inside the config directory of your Elasticsearch installation. So in my PC, this is installed in this directory. So I'll just copy the path and I'll paste it here. So this is inside config certs, and this is the file name, http://ca.cert. So this is required to pass here. And if this is successful, then we want to check if es.ping comes out to be true. If it's true, that means we have successfully connected to Elasticsearch via Python. Okay. So we are going to do some things here. First, we wanted to prepare the data. We'll prepare the data here, and I'll write here. So once we prepare the data, we wanted to convert this data to convert the relevant field to vector using BERT model. Okay, so we'll go one by one. So here we have this data, Myntra products. So I'll just fetch this data inside a data frame. So first we need to import the libraries, import pandas as PD, and then we'll use pd.read_ CSV, and we need to pass the name of this. Okay, this is the name CSV. And I do not want everything, so I will just use .log, and I want only 500 documents from the beginning. And then we'll see the first 5 documents, the head of this data frame. I'll just add the new rows here. Okay, so this got fetched into this df variable. We can see we have product ID, product names, product brand, gender, price, number of images, description, and primary color. So here what I want to search semantically the description of the product. I'll just close this. So I want to search semantically the description of the product. And this is the description. So we will convert this description into into vector by using BERT. So let's just first check if there is any n value present. So we'll see is NA, and we'll do dot value underscore counts. We'll check. So everything is false except this primary color. So primary color has 32 NN values. To handle this, I just wanted to fill NA with the value called none. So none is actually different from NA value because none is kind of a string. So Elasticsearch interpreted as a string. If we just directly try to ingest these kind of NA values into Elasticsearch, it will throw an error. So I wanted to pass this none value here, and I will say in place equal to true. So we wanted to set this action, whatever we are doing. And we'll run this. And if we again run this above cell, everything will come false. So that is good. Now we wanted to convert, let's just delete these cells. We wanted to convert the relevant cells into what you call vectors. So I'll again, let's just go to the SBERT.net. So this is the website from which we are going to get SBERT models. So on this website, if you open pre-trained models here from the left, here you can see all the model names. So we have all these models, and these are the performances given. So this is the performance of embedding. So that means how much time it will take to convert the text into vector. So based on that, this is the performance of each of this model. And performance of semantic search, means that it is basically how well it performs on semantic search. So I'm just taking the average, on an average, it should be good on both the sides because we have to make the embeddings as well. So this performance is 63.3 of this model, all MPNet base V2. If we click on this, we'll copy this model name. And here it is given how to use this model. So we'll copy this code first into our Jupyter notebook. And this is, this is the markdown column. So that is why it is not coming. We'll delete this cell and we'll paste it here. Yes. So we need to install this library as well, sentence transformer. So I'll open my terminal again and we will install this library first. I need to do pip install. So I'm installing all the libraries inside a virtual environment so that it should be a clean setup. Okay, this is getting installed. So meanwhile, we'll just copy the name of this model. We'll get this name, we'll paste it here, and we will run this code after this library gets installed. So while the library is getting installed, this model generates the vector of dimension 768. So this 768 will be useful to us once we define the schema. So while defining the schema, or what you call mapping in Elasticsearch, we need to pass in this dimension as well. So this library is installed. Now we'll cancel the terminal and we'll run this code. So this will take a while because it's a 420 MB model. So it might take a little while because it's a large size based on your internet speed. Okay. So as we discussed, while the model is getting loaded, as we discussed, we wanted to convert this into vectors. So, and we'll convert the vector and we'll call it description vector. So we'll say description vector and we'll equate it to, and we'll apply this function on this. So model has been loaded. Now we wanted to apply, and we'll use lambda function here. And we want model dot encode and we'll pass in the x. So what it will do, it will take each description, it will convert into vector and it will store that vector into this column. So let's just run this and we'll check df.head once again. So let it take it time because we have 500 descriptions. So it will take some time to convert each description into vector. Okay, so as we can see, the vector has been created. If you can see on this right, this is the description vector column, and here are some numbers. So vector is nothing but just an multi-dimensional array of numbers. Okay, so this is looking good. Now we need to create an index. To create an index, first we need to define the schema of that index. So I'll just save this file and I'll create a new file and we'll call it index mapping.py. And here we'll again use the same variable index mapping. And now this is the important part. So we need to define the mapping for each column. So first, this is the standard. We'll write properties here and colon. Again, we'll start one more bracket. And inside this, first we'll write product ID. So we have different columns, right? Product ID, product name, product brand. So we'll copy one by one. Product ID. And now here I wanted to define what type of data is present in this column product ID. So in this column, we have a data of type number. So in Elasticsearch, we call it long. Now we need another column. We have product name as well. So I'll just copy this. So we have multiple columns. I have just copied everything. We'll copy product name. Product name, the type of product name is text. Now we have product brand. And product brand is also text. And we have gender. So gender is text. And we have price. And this is actually number. So we'll keep it long. We have number of images. This is the data type is also number. So we'll keep it long as well. Price, number of images is done. Description. We want to keep description in text format as well. So we'll write description here. And then we have primary color. And this is also text. So I need to change it to text and I need to change this also to text. Now we have one more column, which is vector. So this is kind of interesting. So for this, we will define a different kind of setting. We have description vector here. We'll copy this. We'll open one more bracket. Now here is the interesting part. We need to give it a type. And the type here is dense vector. You can refer to the documentation of Elasticsearch. It is given there. And here we need to pass how, like, what is the dimension of this vector which we are using. So as we have seen in this page, like all MPNet base version 2 will create a vector size of 768. So I have dimensions, 768 is here. Now we need to also pass one more parameter, which is index, and index should be true. So index should be true. This means this column will be searchable. If we do not pass this, this column will not be searchable. So semantic search will not work. Now we can pass one more parameter, and which we call similarity. We have similarity here. So similarity can be of different types. There is L2 norm, there is cosine similarity, etc. You can refer to the documentation. So right now I will use L2 norm. L2 norm is just a normal distance between 2 points, or we also call it Euclidean distance, if you have heard of it. So we'll just save this. Now we'll again go to our index file. Now our data is here. Elasticsearch is a JSON database. We cannot insert this tabular kind of data into Elasticsearch. We have to convert this data into a JSON or a dictionary format. So in Python, we have a function by which we can convert this data into JSON. So before that, first we'll create the index. So as we can see, again, we'll check if our Elasticsearch is still running and we are connected to it. Yes, we are connected. es.ping is true. As above, we have defined this es. Now to create the index, I'll just mark it down to make it more clear. Create new index in Elasticsearch. And to create new index, we'll call es.indices.create. And first we need to pass the index name. So the index name will pass is, we'll say fashion products, or let's just say all products. And after all products, we need to pass the mapping. So here, that whatever we have decided, we will pass this. So we have index. So this mapping, we'll get it from this file. This is the index.mapping file on the left, right? So to first we have to import this. So from this file, from index mapping, we'll import this. Inside this file, we have created one more variable, right, with the same name. So we wanted to import this variable. So from index.mapping file, we wanted to import index mapping variable. And this variable, after importing, will pass in here. And if we run this, it should create new index in Elasticsearch. So if we run this, it is throwing an error. Oh, I think this should be mappings. We'll run this. Yes. So if acknowledge equal to true, that means index has been created. Now I will create one more markdown here, and we will ingest the data into index. So we have this data in the tabular format. So we need to convert it to what you call a JSON format or a Python dictionary format. So there is a function, there is a method in Python by which we can do it. So if we call to_record, sorry, I think this is to_dict dictionary, and inside of it we need records. So if we do this, it will give us an array. So let me just call it record list equal to this. So this ran, and if let's say I wanted to see what is the first element of this array. So as you can see, this is just the vector. We'll scroll up, and you can see we have product ID, product name, product brand. So everything is in the key value pair, which we want. So this is good. Now this is just the one element. So what we want to convert each and every, we want to index each and every record into this all products index. So what we'll do, we'll write a for loop for record in record underscore list. What we want it to es dot index, and here we will pass in the index equal to, this is the index name. Inside this index we want it to insert the data, and we need to pass one more variable which is called document, and in this we'll pass this record. Okay, so if we insert this document like this, it Elasticsearch will automatically give some kind of ID to each and every document, but we have a product ID, so we want to give that product ID to each record. So I will pass in the argument ID as well. ID is present in the record, and we have product ID. So if we go above here, as we can see, we have a product ID for each product. So we do not need any auto-generated ID from Elasticsearch. What I'll do, I'll just put it inside a try catch so that if some error comes, we can see that exception as E, and if some exception occur, I wanted to print it. So if we run this, all documents from this record list will get inserted into the Elasticsearch server. So let's just run it. No error is coming. I think it should be fine. Okay, this ran successfully. So let's just check how many documents are present inside an Elasticsearch index. So we'll use es.count method. We'll pass in index equal to all products. We need to pass the index name. If we run this, so we have 500 documents successfully inserted into the Elasticsearch index called all products. Okay, now we'll search the data from the Elasticsearch. Search the data. Okay, so here user will type some input. Let's call it input keyword, and we want to semantically match this input keyword with description. So right now, let's just say blue shoes. User is searching for blue shoes. Let's assume this. We'll later make a Streamlit UI as well, and we'll convert this to vector. So vector of this input keyword. So we'll make another variable and we'll store vector of this variable. So we have a model, and we'll use the model.encode, and we'll pass this input keyword in this. So this model will encode it into a vector, and this vector will be stored in this variable. Now we wanted to pass this to what you called Elasticsearch. So we will write one query, and we'll pass in the field. So we wanted to match it with the field. If you remember, the field name was description vector. So we wanted to match this blue shoes vector to all the description vectors present in our database. So that is why we are writing this, and we'll pass in the query vector as well. So in this, we have the query vector as this. So we'll pass in this. We want number of results to be shown as, let's just say we want only one, let's say 2 results we want. And there's one more parameter here, which we call number of candidates. So number of candidates is 500. So these are the 500 documents it will search to match with. We have, now we'll pass in the variable results. We'll call it res, and we'll say es.knn. Basically now we are interacting with Elasticsearch. knn.search. Here we have to pass the index name as well. So we have the index name, all products. And we'll pass another keyword argument. This is knn, and we'll pass in this query into this keyword argument. Now if we search with this will give us the results, but inside that result, vector will also be present. So it is not very pleasant to look at like those 768 dimension vector, and it will take a lot of space here. So what I'll do, I will not fetch everything. Like I'll not fetch each field. I'll only fetch some fields out of it. So let's fetch product name and product description. So the field name was description. So everything will be stored in this, and inside this the result is present in. So this will give us the result in a JSON format, and in that JSON the actual results are present inside this JSON, and then hits key, and then again hits key. So let's just run this code. So if we run this, it is showing an error, KNN unknown field. Did you mean field? Okay. Oh, I have written field filed here. Let's just run it again. Okay. So we have the result, and as we can see, we have the product name as Puma Men Blue Sneakers, and the description is a pair of round toe blue sneakers. So our blue shoes is matching with blue sneakers. So we have kind of created the semantic search. We just need to implement this function into the Streamlit UI now. So just to save time, I have already created this file for the UI, and I will walk you through it. So I'll just paste it here, and we have this search app.py. So what we did, we have imported the Streamlit as st, we have imported the Elasticsearch, and we have imported our model as well, because we need to convert each and every query or typed by the user into a vector as well. So we need this model for that. Our index name is all products. Now this is the same code to connect to Elasticsearch using Python. And here if we scroll down, I have defined one function which will take input keyword as an input, and this is the model which we have used. Again, this is converting the input keyword to a vector. This is the same query which we have written. This code is same, and it will return the results. So results will be res hits hits, as we have seen. Now here is the main function. So here comes the Streamlit UI. So we will define a main function, and we will pass in st.title. So this will be the title of Myntra fashion product page. And let me just install. So in this environment, I have not installed Streamlit. So just Streamlit. So Streamlit is getting installed. So st.title. So this will show the title on the page as search Myntra fashion products. And here we'll take the input from the user. So st text input. So it will, user can type it here. And if user search, if user click on this button, so we are taking this if st.button search, and if this is true, and if search query, if there is a search query present, if this search query is not false, if there is something present here, we will call this search function and we'll get all the results in this variable. Now we need to show the results one by one in a list format, in a pretty format, right? So we'll first write subheader, and subheader will be search results. So before showing all the results, we wanted to give that a heading, and for each result we'll create one container, and that container will be, so this, so I'll tell you what this source is. So if we go to again our search result, and if you can see, there is a source key, and inside this source key all the description, product name, and everything is present here. For the second document as well, source and all the things are present here as well. So we'll go to our search app. So if source and result, so that means if this source key is present in this result JSON, then only we'll show the results. So I have written st.header, source, and the product name. So we are fetching this product name. So this is the nested JSON, right? So first key is source, and then another key is product name. So this will show us this data. Similarly, we want description as well. So we'll like fetch description from the source nested key. And after each result, we'll put in the divider. This is kind of a line. And if name equal to main, we'll run the main function. So we will run this. We have to type the command streamlit run and the name of the file. So name of the file here is search app.py. So let's search app.py. So it will run everything and it will open. So we have opened here. It is loading. Yes. So we have created this search Mindra fashion product as a heading. Enter your search query here. And now we will search for something. So as in the beginning, I have shown you, let's search for a makeup product having a name of a bird. Let's search it. It will show us the results. Okay. Index not found. No such index is present. Okay. I need to change the index name from somewhere, I guess. We have all products. Let's just check. I think I have written somewhere. Okay. So this is the earlier index which I was using. So it is causing the error. We need to pass in the index name properly. So we have this index name. We'll save with this again. We'll close this and we'll run the file again, streamlit.run. We'll close this one. Okay. Make a product having a name of a bird. Having a name of a bird. This should work now. Yes. So the first results, as you can see, there is a peacock in the name. And we have not specifically written peacock anywhere. We have just given the query like make a product having a name of a bird, and it is matching with royal peacock. So this is kind of a semantic search. Let's search something else. We'll call pink shoes having laces. And we'll search it. Okay. So her Invictus women pink solid cushion smart casual derbies. So derbies are nothing but shoes only. And these are the specific kind of shoes, and the color is pink as well. So it is matching with the description. We just need to check if there is pink derbies present in the description. So yes, a pair of pink pointed toe derbies with cushioned footbed. So it is semantically matching with whatever you have written. Let's search one more thing. Let's search collection of ornaments. So ornaments is nothing but jewelry, and we will search it. Collection of ornaments. So as we can see, gold plated sterling silver hoop earrings. And if we can see the description, a pair of maroon gold plated sterling silver hoop earrings has floral details with multiple multifaceted stone embellishments and jhumki dangler with a cluster of beads secured with a stylized insert closure. So there's nothing in, like, there's no word ornament present in the description. Even after that, this keyword is matching with this description. So this is the semantic search. So this is extremely powerful. So I hope you guys got the value from this video. Thank you for watching.